Let's wait until people come. Hello, can you hear me, everyone? Can you see me? Can you hear me? Am I clear to you? Okay. The mic is gahuwada. It's like the voice is coming from the what do you call, from the laptop. I don't know what's wrong with that or how to correct it. Um, YouTube live එකකුත් වෙනවා, so some people are there in the YouTube also. අර YouTube package තියෙන කට්ටිය YouTube එකේ ඉන්නේ. අනිත් කට්ටිය මෙහි. Let's start නේ. People, they have the MSQ too. This one. MSQ too. 30 questions are there. One person asked like to make it like very hard. එහෙම කරන්නේ නැහැ. A-level paper isn't very hard. අර like A plus questions දාන්න පුළුවන්. හරි? Out of syllabus එක දාන්න පුළුවන්, right? Then there's no use of that. This is done for just question practice. You have to have the question practice. In order to have the question practice, only you are doing this. එතකොට then you can see in these questions, like if I take one example, if no two electrons can have same set of four quantum numbers. Now that is Pauli's exclusion principle, right? So likewise, the basic stuff only we are covering. So those things only they are asking in the paper, right? So that is why it is not much harder. ගොඩාක් අමාරු ඕනනම් we are doing the paper class. Paper class එකේ දානවා. I hadn't very ප්‍රශ්න. Some questions are there. It's very tough. හරි මේ ඒක නෙමෙයි. What I want to do is like make you score marks for the A-level model papers. හරි A-level වගේ ඒවට score කරන එක තමයි my target. So එතකොට අර ගොඩක් අමාරුව දාන්න, right? I want to include very hard questions in this. Then okay, we have 30 statement questions. Hurry. Midnight statement question. Either statement questions only you have. There are 30 statement questions. I'm going to start there. People look at the first one. Sigma bonds are always formed from hybridized orbitals. Is this statement correct? People, the people who come to my class and other people are also there in the Zoom meeting and all. Sigma bonds are always formed from hybridized orbitals. Abit, bro, innal. Go. Innal, Abit. Tell me first statement, correct or not? Correctly think. Varadine is wrong. It does again or rational. Varadi. People, මේක දාන්නේ එහෙමයි. හරි මේක අමාරුයි වගේ පේන්නේ. These questions are not hard. මේ question එක මම හදුවා. Right? This is question I made. මේක කොහෙන්වත් MCQ එකකින් ගත්ත එකක් නෙමෙයි. Right? This is not taken from anywhere. I made this question. Right? Sigma bonds are always formed from hybridized orbital. It is not true. If I say you CH4, you have CH4 like this. පළවෙනි question එක ඉවරයි right අර මොකද්ද meme එකක් තියෙන්නේ you are full you are like very ready for the A-level paper and then the first question අර ඊතරයක් කියලා එහෙම වදින්නේ right first question hydrogen here now carbon you know that is sp3 hybridized ne? In the class we drew this in the class we drew everything carbon is like this ne? Carbons this is one orbital this is the other orbital this is the other orbital this is the other orbital sp3 hybridized there are 4 sp3 hybrid orbitals and the next one is hydrogen hydrogen is just one atomic orbital that is not hybridized got it that is not hybridized there can be forming sigma bonds from p orbitals also right directly p orbitals there can form sigma bonds right not always hybrid orbitals for example this and the basic example is this hydrogen is 1s that's not hybridized that is not hybridized right that is not hybridized so first statement is wrong it's a pi bond so false no you're like mixing it up no pi bonds are always formed from unhybridized orbitals pi bonds are formed from vertical overlapping lateral overlapping sorry lateral overlapping I told you in the class these are going to form a ball I mean not a ball donut shaped structure and electrons will move around this right so this is lateral overlapping is what forms pi bonds sigma bonds are formed from hybridized orbitals mostly right sometimes it might not be like that for example H2 two s orbitals right it's a sigma bond two s orbitals not hybridized that statement is wrong can you give me right asking for hard questions ඉතින් ලේසිව කරගන්න බෑ the sigma bonds are always formed from hybridized orbitals වැරදි that's wrong right next up the overall charge of the most stable Lewis structure is 0 correct or not people everyone talk zoom meeting එක අද කට්ටිය අඩුයි නිදිත් දන්නේ නේ last week ගොඩක් කට්ටිය හිටියා okay true correct ඒක හරි that one you're correct because the carbon monoxide it has no charge නෙමෙයි it has a charge කියලා මේ කියන්නේ when you draw the structure it is like this මෙහෙම තියෙන්නේ here minus here plus so the overall charge only they are asking here right yes correct carbon has a negative charge and oxygen has positive charge so the overall charge is 0 they're asking the overall charge is 0 that means we can tell that the statement is true right statement is true okay then next one XeF4 has octahedral electron pair geometry. Correct or not? XeF4. Correct. Everyone correct. Ma'am. Right? So this is octahedral. How do you do it? Like 1, 2, 3, 4, 5, 6. Right? That is octahedral electron pair geometry. Now people tell me what is the shape? What is the shape? What's the shape? Shape of XeF4. Right? What's the shape? Scar planar. Good. Square plane. Square plane. So this is correct. They're asking the octahedral electron pair geometry. That is correct. Next. BF3 is a polar molecule. Like lazy. Correct or not? That one easy. Correct or not? BF3 is a polar molecule. Ekenek true කියනවා වැරදි. BF3 is not polar. BF3 මෙහෙම යන්නේ. Right? BF3 is not polar. Like this. Right? Dipole moment of this one to this direction, dipole moment of that one to this direction, dipole moment of this one is to this direction. So as a result, the net dipole moment is going to be 0. Therefore, it is not polar. Right? It is not polar. Next one. SF4 is a non-polar molecule. What do you say about that? SF4 is a non-polar molecule. True or not? SF4. SF4 is polar. How do you say that? Actually, it's an electron pair. I didn't see it. I didn't see it. Fifth one. Wait, look at this one first. SF4 electron pair geometry. What is the electron pair geometry of the SF4? What is the electron pair geometry of SF4? What is the electron pair geometry of SF4? Trigonal pyramidal නෙමෙයි. Electron pair geometry I'm asking. So trigonal bipyramidal නේ. This one trigonal bipyramidal. Yeah. එතකොට when you remove a bond pair to form an electron pair, so what's the shape of it? Shape of this one. Quick. Oh. What's the shape? Seesaw. Shape is seesaw. I'm doing like a revising process to the class students actually. Easy. Those people learned it recently. The dipole moment everyone. If you consider everything, this is not actually, sorry, this is a polar molecule, right? This is a polar molecule. This statement is non-polar molecule false. Fifth question, missed it. O3 is an angular molecule. Let's draw O3. First draw O2, will you? O2 structure. And if you don't know how to draw O3, do it like this. Or you can draw the normal Lewis structure method. I have taught you the Lewis structure method. I mean, basic people do it. So, right? Or else you can do it like this. Like O2 is like this. So what happens is another oxygen will come and attach to here. Another oxygen will come and attach to here. You can think of it like that. Right? Another oxygen will come and attach like this. So when it attaches, this oxygen gets a positive charge. Right? The electrons and this oxygen gets a positive charge. These electrons going to disappear. Right? This oxygen gets a positive charge. Right? This oxygen gets a positive charge. Then this oxygen will remain its negative charge in order to neutralize the charge. Now here positive means there should be some negative somewhere, right? In order to neutralize it. So this oxygen will have a negative charge. You can take it like that. Or you can go with the Lewis structure method. So two possible ways. They're asking O3 is an angular molecule. It is correct. This lone pair is going to push these bonds further away. So what happens is this angle, actual angle, I mean, if this was a bond like this, actual angle will be 120. Since it's not a bond, it is a lone pair, the angle will reduce by 2 more degrees and it will be 118 degrees. 118 degrees. Right? So that statement is Correct. O3 is angular molecule. Right. Next one. S7 turn. Next 7 turn. Electron affinity of chlorine is the highest positive among all elements. True or not? Electron affinity of chlorine is the highest positive of all elements. There are mixed answers. Some people say true, some people say false. Mixed answers. You have to look for what you're looking now. You are looking at the electron affinity. I told you before looking at electron affinity, you have to look at electron gain energy. Right? You have to look at electron gain energy. When you look at electron gain energy, what has the highest negative electron gain energy? And a phone calls variation that is electronegativity. That is for electronegativity. This is electron affinity. Electron gain something different. It's different. So electron gain energy highest negative is for chlorine. I told you electron affinity is the exact opposite, right? So if electron gain is negative, then electron affinity is positive. Then if chlorine is the highest negative, chlorine is the highest negative, then electron affinity is the highest positive. That's how you take it, right? One person is asking, electron affinity is the modulus. Modulus kata na. If the electron gain energy is negative, then electron affinity is positive. If electron gain is positive, then electron affinity is negative. It's modulus right? Positive with modulus positive, right? Modulus I know a little bit of maths, bio but I know a little bit of maths. එතන positive එක modulus කියන්නේ negative නෙමෙයිනේ. හරි. So it's not modulus ගාව ගන්න එපා මේවට ඈ. එන ගහන අපරාධ. හරි. එහෙම එපා. Right? What I was telling, electron gain energy is the opposite of electron affinity. Electron affinity is the opposite of electron gain. Right? The only the sign changes. So you know highest electron gain energy is chlorine. That means highest negative electron gain energy, chlorine. So the opposite. That means electron affinity is highest positive also chlorine. Right? Chlorine, if we say in basic words, like chlorine likes to gain an electron and also it doesn't like to liberate an electron. Highest positive means it doesn't like to liberate an electron also. Like again, once it becomes Cl minus, now what is electron gain? Cl plus electron goes to Cl minus. This is electron gain. Then what is electron affinity? Electron affinity is Cl minus liberating this electron. Electron එකක් ගත්තොත් දෙන්නේ නැහැ, right? Once he get an electron, he will not give it. ගත්තොත් දෙන්නේ නැහැ, right? ගත්තොත් දෙන්නේ නැහැ. So chlorine after gaining an electron becomes Cl minus and Cl minus will not like to liberate its electron. So highest positive is chlorine. That is correct. Right? That is correct. Eighth one. Magnesium 2 plus iron has no electrons in the 2p orbital. Correct or not? ඒක ලේසිනේ. හරිද? Magnesium 2 plus iron has no electrons in the 2p orbital. False. Correct. Correct. I think magnesium 2 plus magnesium belongs to the third period. Magnesium belongs to the third period. Make and makanna there. Then making and makanna there. Right, I can't erase it now. Whatever. Right, you have magnesium. Magnesium belongs to the third period. Magnesium belongs to the third period, right? So removing 2 electrons means it will remove 2 electrons and it becomes the second period element. So actually 2p orbital electrons, right? There are electrons in the 2p orbital. Easy. Very easy. False. Next one. All hybridized orbitals of carbon in CH4 are equal in energy. They got true the false. Or the MCQs, they're asking these things. All carbon atoms of benzene are all hybridized orbitals of carbon in CH4 are equal in energy. True or not? People. True or not? True, ne? Everyone correct. How do you say like that? Copy karla dena, right? We have discussed. Once they are hybrid now, without hybridization, you have s orbital, p orbital, p orbital, and p orbital. This s orbital is lesser in energy than p orbital. You know that. So these p orbitals are greater in energy than s orbitals. You know that. Once these are hybridized, that means they are combined together. They become sp3 hybridized orbitals. These orbitals are equal in energy. Once they are hybridized, they are equal in energy. Once they are hybridized, they are equal in energy. And once they are hybridized, they are equal in energy. That means the statement is correct. That means the statement is correct. All hybridized orbitals of carbon is CH5 equal in energy. Correct. 10th one. It's going to take a lot of time. All carbon atoms of benzene are sp2 hybridized. Correct or not? Benzene structure. You know the benzene structure, right? Benzene may have the carbon, 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 carbon. Double bond, single bond, double bond, single bond. This is actually not the original structure. This is not how it exists. There is a resonance hybrid. So basically CH4, sorry, C6H6 is this one. Benzene. Right? So if you consider any carbon atom here, all are sp2 hybridized. All are sp2 hybridized. So that's it. Right? That's it. That means all carbon atoms. Oh, I can remove this. Oh, there you go. All carbon atoms of benzene. Now I'm new to this, right? I am new to this. This is my second midnight session. So that's why I'm learning still this stuff. Even Zoom annotation, right? All carbon atoms of benzene are sp2 hybridized. Next statement. අහන්න කලින් false කියන්නේ පාරයි තාම ඇහුවේ. Next one. Next one. 11th one. All carbon bonds in bond lengths of benzene are equal in length. All carbon bond lengths are equal in length. Pavitran, you're 2024, right? If I can remember. I have seen you in the group. Or are you another one? 25, me? No. I have seen you somewhere. You have talked to me in WhatsApp, right? I can remember. Yeah. People, 11th statement. When many of you got it wrong. Was name correct. Resonance hybrid. Other keyword. Today I told this. Today in the class I told this. Resonance hybrid. In a resonance hybrid, all bond lengths are equal in length. If you consider carbonate resonance hybrid, that means if you draw carbonate like this, carbonate can we have it? You will draw it like this. But actually, this is not how it exists. This is not how it exists. This pi bond can move. This pi bond can move to here or to here. It's a hybrid. The pi bond can vary. It can stay here. It can go here. It can go here. Right? It can vary from one place to another. Therefore, all carbon ox. Yeah, Schrodinger's pi bond. මම අද කිව්ව ක්ලාස් එකේ Schrodinger's cat scene එකක්. ඒ වගේ තමයි, right? For checking bond length, we should consider resonance hybrid. Yes. You have to consider the resonance hybrid, then you have to get the bond order. In the class, I told you how to get that. It's a long stuff. I told you how to get and stuff. It is the meeting in the class. I told you how to get and stuff. All carbon bond lengths of benzene are equal in length. Yes, all carbon bonds are actually in resonance. So when they are in resonance, all the bonds are going to be equal in length. all the bonds are going to be equal in length. Why? They are in resonance hybrid. All bonds in a resonance hybrid are going to be equal in length. What about bond energy? Bond energy එක වෙනස්. Again, bond energy ගැන how much energy needed to be supplied for breaking a bond නේ. එතකොට ඒකත් ඉතින් equal ඉතින් හරි. Except one case. There is one case in halogens. Halogens වල අර bond length variation FL2 CL2 BR2 I2 කියලා හැම එකක් තියෙනවානේ. Their bond length, however, is obviously increasing like this, bond length. But bond strength of them, that is bond energy of fluorine, bond energy of fluorine is actually here. Now, again, if we write the bond energy, full track. Bond energy, you expect it to be like this. The shorter bond length, harder to break. Shorter the bond length, harder to break. Right? BR2. Shorter the bond length, harder to break. Okay. Shorter the bond length, harder to break. F2, you assume it to be harder to break, but no, it's not like that. What happens is this fluorine or F2 is actually belonging to here. Why does that happen? Because two fluorine atoms are very highly negatively charged. That means small radius. Fluorine atom has very small radius. So either they are very close together, but the thing is actually they are like repulsions are very large. If we put a small body thought of the one Galileo, right? Their bond strength is bigger. That means bond energy is lesser. That means the energy needed to break the bond is lesser, right? Your question, what about the bond energy? In that one, in benzene, yeah, they are equal in bond energy. Hurry. This one additional point I should tell you. All carbon common bonds are equal in energy. Correct. Hurry. Next one, 12th one. Fever. Tell me. S2O32 minus and PCl4 plus have same shape and electron pair geometry. S2O32 minus, let's draw. S2O32 minus. This one minus, this one minus. S2O32 minus and PCl4. Hari මෙහෙම එකයි. Hari PCl4 plus. PCl4 plus කියන්නේ at the center you have positive charge. That means phosphorus electrons 1, 2, 3, 4 atoms. 4 electrons are only there. They are 4 positive. Hari. So electron pair geometry is also same. Bond, shape is also same. What is it? Tetrahedral, right? Tetrahedral. So, 13th one. Metallic bonds are formed between metals and non-metals. Is it correct? Like a basic definition, we have talked about it. This is a basic definition which you talked, right? Yeah, metal and metal. Metallic bonds are formed between metals and metals. This is false. NO2 plus has a linear electron pair geometry. Correct or not? Correct or not? True. Correct. Right? True. NO2, if you draw it, you are going to get a linear electron pair geometry as well as a shape. It is linear. Both are linear. Next up. Presence of a charge on oxygen atom of a bond system makes it unstable. Correct or not? Presence of a charge on oxygen atom of a bond makes it unstable. Most of you are saying the correct answer. Good name. You people are good. Yeah, correct. Only a plus charge will make it unstable. Negative charges are unstable in there, right? Only a positive charge. Good. Correct. So this is false. When oxygen atom gets a positive charge only, it becomes unstable. If it gets a negative charge, it will not get unstable. Right? Next one, 16th one. When VSCPR units are 4, then the hybridization will be sp2. Take a lazy. What is the hybridization of 4 VSCPR units? What is the hybridization? Correct answer, sp3. Correct. Then make it 17th one. Superoxide contains an odd electron. Correct or not? People who come to my class make a karapi. We did this in the class. Alright. The class are saying the correct answer. People who came to the class saying the correct answer. I can see that. True. This was an example in the tube. Superoxide, right? Superoxide, if I draw the structure for other people also, you can see uh, like this. Superoxide actually make color high and I'll use red color. You have oxygen. You have another oxygen. Now, what is peroxide? Peroxide is this one. O2, 2 minus. There are two oxygen atoms and both contains a negative charge. Here minus, here minus. So superoxide means O2 minus. That means O below 2 and up minus. O2 minus. That means this negative charge should disappear. How do we make it disappear? We have to remove an electron like this. And now there's no charge here. There's only a charge in this one. That means O2 minus will go like that. That is superoxide. It contains an odd electron. We talked it under odd electron species in Lewis structures. Lewis structures. Yes, Lewis structures. Special Lewis structures. Under that only we talked. Right? Okay. Superoxide contains an odd electron. That is correct. NO2 bond angle is greater than 120, a plus point. NO2 bond angle. We didn't talk about bond angle variation. That's why you are telling the wrong answer. Bond angle variation on Friday. Sunday we are going to discuss. Pavitran correct. Abhita correct. I told for some people I told this thing. People, this is a something which is not in the syllabus. This is something which is not in the syllabus. It has single electron. That single electron makes the bond angle larger than 120. You expect this to behave same as a normal electron pair, but it's not. You expect it to be 180. It's not. This single electron causes this angle to increase up to 134. Note it if you don't know, or you can search Google if you don't trust me. Search Google. NO2 bond angle 134. Right? Why is this happening? Because this repulsion given by this electron is not enough. The angle tends to increase than a bond, right? Now, if it was a bond like this, if it was a bond, then it will be 120. Now it is greater than 120. So that one you need to know. If they ask you to write the bond angle variation, you have to consider NO2 to be 134. It is larger than trigonal and 1, right? It is larger than trigonal plane. Right. Okay. Correct. 19th one. The mass of an electron is inversely proportional to the wavelength. Correct or not? De Broglie equation. De Broglie equation. Very good. Abhita, palaini class ekana first class. Remind of the first class. First class which we did. People, if you look at the equation, it looks correct. If you look at the equation, lambda equal h of mc, right? OMV. It looks correct. Mass of an electron is inversely proportional to the wavelength. Looks correct. But Yeah, wavelength equal Planck over MB. That's what I wrote. Hari. Although it looks like that, mass of an electron is a constant. Okay, then our physics. In physics also they will give this. Young's modulus, like F equal A Y over L multiplied by E. That one you have, this is the extension, right? This is the extension to the original length. This one cross-sectional area, and this one is the force. So they will say like force is directly proportional to the Young's modulus. Young's modulus will not change with the, it will change only with the metal, right? Only with the type of metal. Here, mass of electron will not change ever. Now don't bring Einstein's relativity thing. I am talking about chemistry, A-level chemistry. Mass of electron will be a constant. Mass of electron you can't change according to A-level GC chemistry, right? You can't change. So although this shows a relationship like that, you can't change the M value. Now think in your Poisson equation. In Poisson equation, you have pi, you have pi, right? Q dot equal Q dot is proportional to pi, right? Q dot is proportional to pi. So this pi value, although it is proportional, you can't change it. It's a constant. Mass is also a constant according to elements. Right? You can't change it. Therefore, the statement is wrong. Right? Therefore, the statement is wrong. 20th one. 20th one. An electron can move at the speed of light. Electron can move at the speed of light. Electron can move at the speed of light. Right. Most of you are correct. Electron cannot move at the speed of light. According to Einstein's theories, once you approach the speed of light, the mass becomes infinite. The mass becomes infinite. Hari, එතකොට අර මං කිව්ව electron එකේ mass එක change වෙන්න බෑ. I told like electron's mass cannot change. ඒතර ඕවා හිතන්න යන්න එපා. Don't think that. My point is nothing can reach the speed of light except light. Except a photon. Nothing can reach the speed of light. Right? Nothing can reach the speed of light. That one wrong. That one wrong. This one wrong. 21st. When n equal to L can be -2. Correct or not? When n equal to L can be -2. False. Yeah. Good. I'm happy. Right? I'm very happy. L is going to be less than and equal to n-1. That means when L equal to the possible values for what you call, sorry, when n equal to the possible values for L are going to be -1, 0, +1. Actually, these are the 3 p orbitals. We talked this in the last MSQ also. Right? Right? Same thing. So that one is wrong. That one is wrong. 22nd, the number of d orbitals for any energy level is 5. Correct or not? Lazy. For every energy level, there are 5 d orbitals. You know it. On a false clue. It is true. For any energy level, if you consider, there are only 5 d orbitals. Right? Only 5 d orbitals. In the periodic table also, you have 10 elements. We have 10 elements means 10 electrons, which can be filled into 5 orbitals. Sorry, then 22, it's going to be what? Number of d orbitals for any energy level 5. That is correct. Radii of H minus. That point I didn't think. Yeah, correct. That person is correct. Yusuf, you are correct. Mummy prashne demme eka amataka vela. There's one point here. Thank you. Good. First and second energy level doesn't have d orbitals. Good point. Good point. When n equal 1, you don't have d orbitals. When n equal 2, you don't have d orbitals. When n equal 3, only you have d orbitals. Good point. People who said correct, convert it to false. Very good. Alright, patta. Patta, right? Like your confidence level is high on this. It's about like a mark like right? Number of d orbitals for any energy level is 5. That is wrong. Right? There cannot be d orbitals for first energy level and the second energy level. Good. Next up. Next up. Radii of H minus is larger than beryllium. Correct or not? I told this today in the class. Physical students in on. I told this today in the class. Physical students. When hydrogen is actually just one proton and one electron. People, when hydrogen gains one electron, the size becomes very large. This point is not in the syllabus, but this point is there actually. You should know it. Like when hydrogen gains an electron, it becomes uncontrollable. The proton, there's only one proton and there are two electrons. But if you consider other atoms, like if sulfur, there are many protons, right? So if you increase 2 electrons, it doesn't affect much. But here, proton to electron ratio is 1:2. That is too much. So one proton is like very hard to control these 2 electrons. So electrons are rotating in big circles. Therefore, the radius becomes extremely large. So it's larger than beryllium. You don't have to know the exact variation, like up to what level it is large. You just have to know like hydrogen H minus is extremely large. They won't give this in the atomic radii variation by end, but they will not give this. Right? They will not give this. Then radii of H minus is large. Correct. 24th, there are 6 resonance structures that can be drawn for SO for 2 minus. Correct or not? You have to draw and see it. There are 6 resonance structures that can be drawn for SO for 2 minus. මම මෙතන අඳින්න යන්නේ නැහැ structures ටික. මම last එකේ ඇඳලා තියෙනවා like 2 times I have drawn. One in the online class, one in the physical class. Sulfite, draw the Lewis structure. Then always look at how many structures are possible. නෑ එදා මම අර කියූප් එක මම online class එකේ මාරු කරා. ඒක මට ඒ වෙලාවේ පැටලුණා මේ. There are 6 resonance structures. ඒක අඳින්නේ මෙහෙමයි, right? මෙහෙමනේ. Now sulfite එක like this. Sulfite is like this. This minus and here minus. Now this double bond can move. This double bond can be here like this. ඒ කියන්නේ මෙහෙම L එකක් තියෙන්න පුළුවන්. Or else it can be like this. That means this double bond come to here like this. මෙහෙම එන්නත් පුළුවන්. I mean මේ L එකෙන් පෙන්නන්නේ the double bond orientation, no? Double bonds can be like this. Or the 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 double bonds can be like this. Like from top to bottom. That means one double bond here and other double bond here. Or else it can be like this. මට ඒකද physical class එකේ I was like අර මෙහෙම ගියා ඒක හරියට ගන්න බැරි වුණා. So this is the method. අර always look from outside without drawing structures. Look from outside like okay, how many structures are possible? How many double bonds can we include? අන්න එහෙම තමයි ගන්න, right? ඉතින් මම මේ question එක දැම්මෙත් ඒක හින්දා I put this question into this MSQ because of that reason. එදා මට physical class එකේ ඒක වැරදුනා. So that's it, right? Sulfur can exist octet. Yeah, it can exceed octet. You're correct. Right? Sulfur can exceed octet. The statement is correct. Twenty-fifth. All p orbitals of an atom are equal in energy. Correct or not? Correct or not? All p orbitals of an atom are equal in energy. Correct or not? People. Correct or not? Correct or not? Huh? Tell everyone. Hmm. False. Why? Suffering. False. P orbitals. It can be 2p, it can be 3p, it can be 4p, it can be 5p. Right? It can be 2p also. 2p orbitals are greater in energy or less in energy. Then I am going to tell a statement like 2p energy orbitals are greater in energy than 3p orbitals. Is it correct? 2p orbitals are greater in energy than 3p orbitals. Is it correct? It's false. 3p 3p means n equal 3. That means higher energy. Higher energy means 3p orbital will have higher energy, right? 3p orbital will have higher energy. Then this statement is false. Now this statement is important because like metana people all p orbitals. Ekai metana වැරදි, right? That is why it is wrong. Otherwise, in one energy level, the p orbitals are equal in energy. Px, py, pz. All three p orbitals are equal in energy for one orbital. But if you like jump from one orbital to another orbital, again one energy level to another energy level, then the p orbital energy is going to change. Right. 26th. Second ionization energy of boron is larger than lithium. ඒක දන්නේ නැත්නම් don't do chemistry, right? හරි. ඒක මොකද්ද? First answer. Right, ionization energy ඒක මොනවද? What is that? මෙහෙම ගියා, මෙහෙම ගියා, මෙහෙම ගියා, මෙහෙම ගියා නේ. Right. 24th question problem. Why? What's the problem? 24th. No, no. When drawing Lewis structures, there is a rule. If you make a bond, you're asking triple bond. Let's draw and see. මෙහෙම මෙහෙම good point. Lone pair to pi bond to lone pair. It's possible. I didn't see that. මෙහෙම පුළුවන්. That is it. That means you are telling this one becomes positive and forms a triple bond, and this one becomes negative. Correct. You have to change it. There are 6 resonance structures for SO42 minus. That is wrong. You people are good actually. Next, not good. The thing is like that I should be there. එතන මේක වැරදි කියලා පේන්න තව එකක් තියෙනවා. That one I also had in the old days, like in my classes I went, some teachers were like මේක මෙහෙම තමයි. ඒකට degrees ඔක්කොම තියෙනවා. chemistry පුළුවන්. හොඳටම පුළුවන්. හරි degrees තියෙනවා chemistry පුළුවන්. But we have sometimes we can point out, so this is wrong. Right? Yeah, you're correct. හරි? so this is wrong කියලා කියන්න පුළුවන්. That feeling once you do that is very large. Cert very you get that feeling that that should be there. If you do it once, then you will have the confidence on yourself. Like I had that those days. So mama like in online classes and no, me වරදිනකම් හොයනවා. හරි වරදිනකම් බලනවා. That is good. Yeah, Google tells 6, but in A levels එහෙම ගන්න පුළුවන්. This can be taken. ඇයි දන්නවද? Like it is possible නේ. Resonance structures. දැන් මෙතන in Google, the way you search, they are going to tell different structures. Now, if they ask, like I told you this in the class, there are existing resonance structures. If they ask existing resonance structures, this one you can't take. If they're asking existing resonance structure, I told you this in the class, the existing resonance structures, you can take this. Or acceptable resonance structures, you can't take this. Or acceptable risk structures, right? It don't make that. If they ask you to draw all resonance structures, now in this question I have told you there are 6 resonance structures. Again, you have to consider everything. Did you understand? Everyone? You have to consider everything. If you are given with a pen and a paper and they ask you to draw the resonance structures, then you have to draw everything possible. Or if they ask like this, like draw the acceptable resonance structure. This word is important. Acceptable resonance structure or existing resonance structure. Those two are there. You can't take this. Why? Those things don't exist. Now do you get it? Everyone. Everyone get it? Go. This is false. Hurry. Resonance structures. How many resonance structures possible? This triple bond, you can change it. You can change the triple bond position. You can change the triple bond position to this one, and this one. There are 4 more resonance structures. So there are 6 resonance structures which are like acceptable, and there are 3 more resonance structures which are like 3 remaining. 6 resonance structures normal. So this one is other one, 7th one. This is 7th one. If you put it here, then 8th one, then 9th one, here 10th one. Yeah. There are 10 possible structures. Right? That is the total amount of structures possible. හරි. මේ ඒක එහෙමයි. අන්න ඒකයි MSQ තියෙන්නේ. අර නිකම්ම like doing theory ඊට පස්සේ past paper questions we are doing then model paper questions අර එහෙම නෑ. MSQ එක කරන්නේ ඕක හින්දා, right? This is not just a class. මේක නිකන් class එකක් නෙමෙයි, right? This is not just a class. This is where you grow. Next one. Second ionization energy ඒක කරන්නේ. ඒක හරිනේ. Second ionization energy of boron is larger than lithium. So ionization energy variation ionization energy variation like this. You have lithium, beryllium, boron. Lithium, beryllium, boron. So what do you do? First ionization energy, you look at this graph. Then second ionization energy, you shift beryllium to backward and boron to back, right? One back. You put it one back. So beryllium will actually come to here, boron will actually come to here. That means second ionization energy of boron is larger than lithium. So boron will be here. Lithium will actually go to the other one again, helium's position. Helium මෙහෙ තියෙන්නේ. So lithium will go to this position. Right. False. 27th one. That is perfect theory. No 2 electrons can have same set of quantum numbers. Pauli's exclusion principle. Yeah. It is true. Hydrogen spectrum has only 4 lines in the Balmer series. Correct or not? True කියන්න එපා. Don't say true. False. Why? In Balmer series, there are not only 4 lines, there are more than that. I said you only the first 4 lines are visible. Then after that, you have UV lines. If some person said like Balmer series contain only visible light, that is also wrong, right? So Balmer Gaussian bracket. No, I'm talking about Balmer series. All electrons that will excite and fall to the second energy level, it will be Balmer series. Now A plus point. And then resource. The hydrogen spectrum has more than 4 lines, right? So it is like visible and the UV light also contain. So first 4 lines, alpha, beta, gamma, delta will be colored. That means red, green, blue, violet. They will be. Then after violet, you have to go to ultraviolet. Ultraviolet is invisible, right? So in Balmer series also you have ultraviolet rays. So this statement is wrong. 29th one. 29th one. Shielding effect of lithium is less than that of sodium. Therefore, the atomic radii of sodium is larger than that of lithium. People saying true, true. Others, false. People who are saying false, can you explain why? People who are saying false, can you explain why? People who are saying false, can you explain why? Hmm? Can you tell me a reason? Like why? Like, become false. I'll tell you the reason. Shielding effect of lithium is less than that of sodium. This is correct. Because lithium is like this. Lithium has only one shell inner. That means one electron here, one electron here. So next electron of lithium is like this. So shielding effect of this electron, that actually lithium's valence electron, only 2 electrons are there. So shielding effect of lithium is 2, right? Shielding effect of lithium is 2. Then atomic radii of sodium is larger than that of lithium. That one also true. But people, මේ මැද තියෙනවා therefore කියලා එකක්. Therefore, the atomic radii of sodium is larger than that of lithium. මේක මං හදපු ප්‍රශ්නයක්. මෙහෙම තිබ්බොත් you can't take it correct. Therefore, ඒක විතරක් නෙමෙයි, not only the shielding effect, there is the nuclear attraction which causes the atomic radii variation. Atomic radii variation is a result of 2 things. It's a result of 2 things. What are they? The shielding effect and the nuclear attraction, right? So the resultant of that will be effective nuclear attraction. Because of effective nuclear attraction, only the atomic radii will vary. Get it? Therefore, right? So in statement questions, they will say in the first statement they will give lithium has less shielding effect. And in the first statement, they will say like atomic radii of sodium is larger than that of lithium. Correct. Second statement, lithium shielding effect of lithium is less than that of sodium. You would correct. Now you have the problem whether you put 1 or 2, whether it explains or not. On the A point, that is what I catched here in this question. Whether it explains or not, you have to say. 2, right? 2. It doesn't explain why. Not only the shielding effect, it's like the nuclear attraction also. Hurry. So both should be mentioned. Yeah, both should be mentioned. Nuclear attraction, nuclear charge is same when nuclear charge is not same. Why? Number of protons are different. Sodium and lithium, number of protons are different. Nuclear charge is not same. Hurry, people. Next one. Next one, here. Shielding effect of lithium is less than that of sodium and the atomic radii We took it as wrong. 30th one. O3 has only 2 resonance structures. O3 has only 2 resonance structures. Correct or not? It's true. O3 has only 2. According to GCE levels. Lone pair pi bond to lone pair. Only 2 possible structures are there. Right? ඒක හරියට නේ. Only 2 resonance structures, that is correct. Here, Abid, I didn't understand what you said. Didn't the concept of resonance structures resonance count? Here, what the hell? People now here they have completed the tute. MSQ number 2 completed. Any questions you want to ask? Any questions you want to ask? No? Anything? Nothing? Revision class. Revision class. It's actually I'll say in the group. Groups and you're in Rankers Club, right? You're in the Rankers Club, so I'll ask in the group. I'll tell in the group. Like they found resonance exists because they measured the bond. They found resonance exists because they measured the bond length and they were equal length, right? Resonance hybrid, you're telling, right? Yeah, maybe. In benzene, when you will learn this. Like they will measure the bond length of what you call benzene and they are equal in length. Again, ඔය හිතනවා වගේ අටි රූලෙන්ම ඉන්න බෑ. You can't measure with a meter ruler. එහෙම බෑ. හරි. There are special techniques. They are out of reach. They are out of reach. Yeah, it might be a reason. Right? It might be a reason. Okay then. Work now. You are like now 11, right? You can work until 12 or 1 if you're like waking up and studying, or else you can sleep and wake at like 4 or 5, then continue. SAT method, now I told you in the special meeting, SAT method and stuff. That's very effective. Like you can track your progress and all using that. For nuclear charge, number of protons minus. No. That is effective nuclear attraction. I said this in the class number 1. Nuclear charge, that means attraction actually. Nuclear charge will be the number of protons. Hari, can a nuclear charge can number of protons. Hari, number of protons. The shielding effect is the amount of electrons that is in between the electron you consider and within that. That means if you consider lithium, the valence electron of lithium, the outermost electron is outside. There are 2 electrons within that. That means the shielding effect will be 2. The effective nuclear attraction will be the nuclear charge minus the shielding effect. That means the number of protons minus the shielding effect. Okay. Here now. Harry. Okay, then people. Next week we are starting inorganic. Inorganic first class. They are keeping it free. Cat analysis, anion analysis, thermal decomposition, and S block reactions they are doing in that tute. Tute is shared free in groups. I'll share the tute when the time comes. Stay alert, stay in touch. Rankers Club 2025, right? RChem 2025. So you have the discussion group. You can ask questions there. You might get answers to that. The product active money than that group figure. Last year WhatsApp group was active. එතකොට ඒක කට්ටිය හැදෙන්නවා. That after time only they will feel that තාම නැහැ, right? There are like 588 members or something in that group. ඒත් ඉතින් Telegram, some people are like Telegram හරියන්නේ නැහැ. Like WhatsApp ඉල්ලනවා සමහර කට්ටිය. Rankers Club please make a WhatsApp group. ඉතින් එහෙම බෑ ඉතින් right. අර Telegram එකේ you can put any amount of members there. ඒක හින්දා තමයි. හරි. Okay. Okay then. See you again in the next MSQ then. Division students in the next class tomorrow online. Ne? Hare? Right. Okay. Good night and bye bye. Okay.